Hi folks, we're going to take a look at page 263, number 8. So they want us to find the equation of the tangent to this curve that's also parallel to the given line. All right, so since our tangent needs to be parallel to this line, it means it has to share its slope. So first thing I'll do is write in slope-intercept form. So we have y equals, this is going to be 3x minus 9. Just brought the minus y to the other side. And so what we get out of here is that the slope of the tangent needs to be equal to 3. All right, and how this helps us is that we need to find what x value would have a derivative of 3. Okay, so first I'll start by finding the derivative of y. Derivative of x is just equal to 1 minus, okay, now here I have to use a chain rule. So my u is my negative x, so derivative of e to the u is just e to the u, so e to the negative x, and then I have to multiply that by the derivative of negative x, which is just negative 1. All right, and when I simplify, we just end up with 1 plus e to the negative x. All right, but I'm only looking for the x value where the derivative or the slope of the tangent is equal to 3. So I'm going to equate this to 3. So now I just have to solve. So I have e to the negative x is equal to 3 minus 1 is 2. Take the natural logarithm of both sides. So if I'm working with e, I'm going to take the natural logarithm. So ln of e to the negative x is just going to be negative x. And then here I'm going to have ln of 2. So that means that the x value is negative ln 2. All right, so let's see what we have now. We have the slope of the line. We have the x value for a point on the line. The only thing I'm missing is the y value. All right, so we're going to take this x value, put it into the equation of the curve. Notice I'm not putting it into the equation of the line. This is not necessarily the tangent. It's just parallel to the tangent. All right, so let's do that. So I'm going to take y and evaluate that at negative ln 2. So what do we have? We have negative ln 2 minus e to the negative ln 2. All right, and so let's just simplify this. So negative ln 2, and here these things just become positive. So I have e to the ln 2. These are inverses of each other. So I just get the original input of 2. So just minus 2. All right, so here is all the things we need to find the equation of the line, because now I just have to stick everything into y equals mx plus b and solve for the b value. So the y value of a point is negative ln 2 minus 2. The slope we found was 3. The x value is negative ln 2 and plus b, so we'll solve for b. All right. So here we have negative ln 2. This here is going to be minus 3 ln 2, which I'm going to bring to the other side. So it's going to be plus 3 ln 2, and then minus 2. Might as well just put the like terms together right away. So b is just equal to negative 1 plus 3 is 2 ln 2 minus 2. All right, so now we have the equation of the line. So y is equal to, slope was 3 times x plus my b value, which is 2 ln 2 minus 2. All right, so let's just do a quick recap. So this is type of problem we've solved a lot before. We just happen to be working with a more complex function. So when we find the equation of a tangent, so in order to find the equation of a line, we need a point and a slope. The slope was gotten by the fact that it was parallel to this other line. And then we used the fact that the derivative had to be equal to 3 in order to solve for the x value of our point, and then we just stuck that into our equation to find the y value, and then we solved for the equation of the line. Okay, that's it for this one.